Hello everybody, and today we're doing 4-2 notes, rate of change, and slope. So let's get right into it. Let's recall that the slope of a line is rise over run. All right. If you forgot what that means the change in y over the change in x. And sometimes you'll see it like a little triangle y over a little triangle x. So what we're doing here is we are trying to find the difference between the x's and y's, or the rate of change, and when we do that, we will find the slope. So let's just take a look at this first example over here. It says find the slope given at least 2 points. So we're just going to go through this whole 3 coordinates here and see if we can practice finding the slope. So the first method we talked about is using this table. A lot of people like using the table. They find it a little bit easier to organize their work here. And what you're going to do is you're going to put your coordinates x and y in here. And what you're going to do is you're going to actually find the difference between these. And how people do it is like, hey, what's the difference between -1 and 2? Well, that's 3. And they'll say, hey, what's the difference between 2 and 8? And they'll say 6. And then the same things with the y's. What's the difference between 9 and 5, which is 4? Difference between 17 and 9, which is 8. And at first glance, you're probably thinking to yourself, this is not a linear function because the slopes are not matching up. But remember, it's rise over run, and so that's 4 over 3 here. And then if we can compare these ones, it's going to be 8 over 6. But remember, I can reduce this 8 over 6 if I divide both top and bottom by 2. So then I get 4 over 3. So actually, the slope is 4 over 3 for both. So this is a linear function, and that is how I find the slopes using a table. All right, the next one requires using a formula, and using a formula, you need to get to a point where you can start doing it. So how you do the slope formula is slope is equal to y2 minus y1 over x2 minus x1. And all that's saying is you're going to choose an x and y coordinate, and you're going to subtract them in the same order. Okay, for example, let me zoom in here. Let's just have this be my x1 and my y1, because that's the first x coordinate and the first y coordinate. And then let's just have this be my x2 and y2. And all I would do is just plug them simply into the equation here. And so I'm going to say, hey, my slope, sorry, that's not the right thing. My slope, or my m, on y equals mx plus b is, it's going to go y2, which is 0 minus 3 over, then we are going to go my x2, which is -2, and my x1, which is -2. So I'm going to have -3 over a -4, which is actually positive 3 over 4. There you go. That's how you find the slope there. Let's do one more just to deal with a little bit more negatives and stuff like that. And I'm going to maybe confuse you here a little bit, but why not confuse you a little bit? And I'm going to call this x3 and y3. And again, I'm just going to plug them into my equation. This time I'm going to choose any 2 coordinates. Why don't I choose this one and that one to make it a little harder here and see if we can do this. So I'm going to choose my x3s first and my y3s. So I'm going to have the slope is equal to -6 minus 3. And then I'm going to have -10 minus 2. And let's see what we come up with. -6 minus 3 is -9. and that is negative 12. Well, when I reduce negative 9 and negative 12, guess what? It's 3 over 4. The formula is important because it's a little bit more compact, a little bit more handy to use than just putting the table up all the time, although the table is probably easier to use. But the reason why you need to use this formula too is also this next kind of problem. And you need to write this down because it is in your assignment and it can be a little tricky, and it's pretty hard to figure out using a table, but using this formula for slope, it's actually pretty easy. So what this is asking me is find missing coordinates given points and slope. So it's going to give me a point. It's going to give me a slope. Sorry, it's going to give me points. Still on the points. And it's going to give me a slope. All right, and we need to find this missing coordinate r. And all you're going to do is use the formula. Just use the formula, plug it all in, and it's pretty straightforward. So let me use the slope formula. Remember, the slope formula is y2 minus y1, okay, over x2 minus x1, okay? Zoom in here. And it all equals the slope, which in this case is 3 over 1. Because the slope is 3, remember, rise over run, 3 over 1, can be written like that as well. So all you're going to do is you're going to start putting this together, and we're going to leave r minus 7 on top. That doesn't really change. On the bottom, you're going to know these double negatives here. The double negatives will kind of do that thing there, plus plus, and that's going to leave us with 5 on the bottom. We still have 3 over 1 here. And next, what you're going to do next is you still need to solve for r. You have a fraction equals something else. There's multiple different ways to do it, but I find the easiest way is to do this. Cross multiply. We've done that before. So we're going to have 1 parentheses r minus 7, and then we're going to have 15. Okay, if I distribute that 1, I'm just still going to get r minus 7 equals 15. Okay, then add my 7. I'm going to get r equals 22. Okay, so that's my missing coordinate there. If I wanted to go back and double check, what I would do is say, hey, does 22 minus 7 over 3 minus a negative 2, well, is this going to give me 3? Well, let's find out. Well, if I simplify that, I'm going to get 5 on the bottom. 22 minus, sorry, that was wrong. We're going to have, I don't know why I put plus there, guys. It's minus. And then I'm going to have 15 on there. If I simplify that, I get 3 over 1. Wow, magic. We figured it out. All right, for the next one, it's going to want you to find the slope given the graph. Guys, you've done this before. We've touched on it last unit, but this time we're actually going to kind of do it. So let's consider this first graph. Go ahead and mark your graph as needed. I have a line that goes through 0, 7, which is right here, and then I have 3, 3 right here. And what we're going to do is we're going to find the slope. And so remember, slope is the change in y over the change in x. So all I'm going to do is come here and say, hey, how much did I go down to get to this new coordinate here? And well, that's 1, 2, 3, 4. So I went down 4. That's negative 4 because I went down. And then I'm going to count how many I went horizontally or side to side, and I went 1, 2, 3, side to side. So my slope, or my m, okay, is going to equal to negative 4 over 3. And this is what I call a negative slope. Okay, I'm just going to put negative slope here. Okay, and it's negative slope because from left to right, it's going down the hill. Okay, so that's why it is a negative slope. As you can see, it's like going down a roller coaster. All right, next one again, you can take your time, put your coordinates on here. I have my 2 points is negative 3, 4, and my other coordinate 1, 4, and that's right here. And what it wants me to do is it wants me to go ahead and find the slope given this. So I'm going to say, hey, 1, 2, 3, 4, 5, 6, 7, 8. I went up 8. I went over 1, 2, 3, 4. So my slope is going to be 8 over 4, which you do have to reduce. So in this assignment, make sure you are reducing, okay? So here the slope is 2 because 8 divided by 4 is 2. And, you know, if I were to reduce this, if I didn't know that, I divided both top and bottom by 4, I would just get 2 over 1, okay? So that is a positive slope because from left to right, it is going up the hill, okay? All right, next we're going to talk about no slope and zero slope. So we've talked about these before, but we're going to talk about them again. We're also going to talk about the average rate of change here in a second. Okay, so let's just go into this. No slope and zero slope. Let's do no slope first. No slope, how I always like to think of no slope is like this. No, I put arrows, slope. See how the arrows point up and down on the letter N? That means no slope would be something that looks like this. It is a vertical line, okay? It is not a linear function because it does not pass the vertical line test. It is not a function, I should say. It is still a line, but it is not a function because it does not pass the vertical line test. In the equation, you could see for this would be 1, 2, 3, 4. It'd be like x equals 4, okay? Because x is always 4. All right, let's take a look at zero slope. So zero slope is a little different, pretty similar. So how I like to think of it is if you have the z, you have these arrows going like this, and it's zero slope. And it is actually a horizontal line. We can just put one like this. That is fine. And the equation you would see here would be like y equals 1, 2, 3. Here, it's 3. And guys, this is a linear function because it does pass the vertical line test. And it is actually in the form of y equals mx plus b because like, hey, y equals mx plus b. Well, if my m is 0 and my b equals 3 and I plug those values in, I would just get this. So it is actually in the form we need it. All right, then the last but not least, we need to talk about find the average rate of change of a given graph. The one that you'll probably encounter, it will be, I don't know, let's just do something that looks like this. Let me mark these on my graph here. 1, 2, 3, 4. And let's just put this point right here. Let's just say this point's right here. And actually, what you're going to have, so it's going to be the average rate of change. I just put those 2 points to help me draw this graph. But you'll see something like a curved line of some sort, like this. And they're going to want the average rate of change between those 2 points. So basically, all you're going to do is you're going to use the slope formula. And remember, the slope formula is y2 minus y1 and x2 minus x1. It doesn't matter what order you put your y's in x or what you call y2 and y1, but you have to stay consistent with these, okay? So if I use the second point, I have to use that second point on all my, on the whole equation. So for example, here we have x is 1, y is 1, and here we're going to have x is 4 and y is 1, 2, 3, 4, 5, 6, 7, 8. So again, it doesn't matter which one I call x1 and y1, you'll get the same answer. So for, I'll call this one x1 and y1, and I'll call this one x2 and y2, and I'll still get the same answer, and I'll show you here in a second. So remember, just plug it in. So Again, if I'm going to use this as my y2, then I have to say, hey, 1, I have to use this as my x2. I can't be mixing these around, okay? And then I'm going to subtract 8, because that's my y1, and this is my x1, so I'm going to subtract 4 there. And, oh, what am I doing here? Oops, I made a mistake. So 1 and 8, yes, and then I got 1 and 4. Oh, that's right. Okay, and so I'm just gonna, the ones just kind of confused me there. I had a lot of ones. So I got 1 minus 8, which is -7. Okay, and then I'm gonna have a negative here as well, which is gonna be -3. So my average rate of change between this, so this is the average rate of change here. Is 7/3. That's my average rate of change of this curve. All right, that's all I got for you. Do the assignment. Good luck.